units we've been working with parabolas, and with parabolas you'll notice that parabolas open up and open down. More specifically, we're going to talk about the equations of the parabolas to actually identify what a maximum or a minimum is. Hence the name of today's lesson, called the maximum or the minimum. You remember that all equations for parabolas can be written as this. Y equals ax plus bx plus c. Y equals a, x minus b squared plus q, which is the vertex form. And y equals a, x minus r, x minus s, which is the standard form. And remember, the first form that you see up there, we call the standard form. But you'll notice that all of them have an a value. That a value is usually calculated by actually doing some form of common factor on either the entire equation or part of each bracket in, say, the intercept form or factored form, or from the vertex formation, form x form. Now, the maximum or minimum point of a quadratic function or a parabola, also known as a parabola, you can write that in if you want. I like to write that in so that you remember, occurs at the vertex. And you know that the vertex of any parabola looks like this. Either it does this, or the parabola does this. It opens down. It either opens up or it opens down. And then there are different variations where the bottom of the parabola is either above the x-axis or below the x-axis, or the top of the parabola is either above or below the x-axis. Now, here's what you need to know about a parabola that opens up. If a parabola opens up, then it has a minimum. And it has a minimum when the a value is not strictly less than 0. Let's go and correct that. Let's go and correct this mistake I wrote here. It's when a is greater than 0. The next that we have, sometimes I make these mistakes, is if the parabola opens down, then we want to think that it's sad. And when you think it's sad, we have a negative value for a. So let's fix that as well. We have a being less than 0. So if the parabola opens up, it looks something that looks like this. And you know this is positive. So that means we have our a value over here being positive. Now, if our parabola opens down, you want to think of it as being sad, negative actually, or sad. And then we can say that the a value clearly is supposed to be less than 0. Now, we're going to do some examples, but we have some things we need to fill in so that we make some more sense of this stuff. For the following parabolas, we're going to determine the max and min value and of x, where the maximum or minimum occurs, and we're going to use that. We're going to use the vertex form if it's not in vertex form. So sometimes we actually have to convert. So to convert standard to vertex form, we do this by using completing the square. we do this form by completing the square. Now, we use we basically we can also use other things as well. So let's say we have the intercepts. If we have specifically the x-intercepts, we can use it to also find the parabola, and we've done that in a past lesson. So let's take a look at this equation here. So for this equation, we have x minus 4 squared plus 2. You notice here that a, this is a, there is no value for a sitting in front of that bracket, so we're going to assume that a is equal to 1. Now, because it's positive, that means that this opens up. Now, we need to also know what the vertex is. The vertex of this parabola is 4, 2. Now, based on this information, you know that the parabola opens up, right? So now our vertex is actually happening right there at the bottom of the parabola. You'd have to look at that and determine whether that's a maximum or a minimum. And because it's opening up, it really means that our minimum occurs at the vertex. So when you respond and you tell me whether this is a maximum or minimum, you're going to tell me that from our vertex and our picture, we can say the minimum of 2, which is our y value, happens when x is equal to 4. Now, if you want to, you could actually say the minimum of y equals 2 happens when x is equal to 4. And notice we're using x, we're using the 2 and the 4 from the vertex. And you notice our minimum, when we're referring to that, we're talking about how low the parabola goes to. So now let's take a look at this other parabola here. This next parabola, question number 2, basically has this equation, right? You know that this is our a value again. And in this case, a is equal to 1. Now tell me, a is negative. What is it telling you? It's telling you that our parabola is opening down. It's sad. So you want to think of it as the parabola doing this with our vertex at the top of the parabola. Now, that means this parabola opens down. Okay? And because it opens down, you also know other things about it as well. You also know from our vertex form that the vertex is 1, negative 7. So now when we do this, we're going to say the minimum, is it the minimum or the maximum? I think it's the maximum. The maximum of y equals negative 7 occurs, or happens, let's say happens, when x is equal to 1. And we're done. Now we have just stated all that information. Let's do that one more time for question number 3. So now for question number 3, we have the same type of problem. We need to know what our a value is again, so we always identify what our a value is. In this case, our a value is equal to 3. So a is equal to 3. So a is positive, so this is a happy parabola, which means it opens up. When I'm thinking it's happy, I'm thinking that it looks like a smile. So if you think about it, and our vertex is at negative 8, 15. So that's somewhere over here on my parabola over here. That's my point. And then my vertex, and because it's a happy parabola, it has a smile on its face. going to tell me based on my picture that the minimum of y is equal to 15 happens when x is equal to -8. Now for this last one here, remember how we used to go and take a look at the information on our basic standard or standard parabolic equation? We would identify the A, B, and C. So if I looked at this, I don't really care about the A, B. I don't care about the B and C's, but I do care about the A's. I would tell you right off the bat that A is equal to 1 based on this standard equation. So we'd have A is equal to 1. Now, because A is positive, we know it's a positive thing. It's a happy thing. So that means it opens up. Now, we don't know what the vertex is, and it's in standard form. So what we have to do is we have to complete the square. So we're going to take a look at this and determine what the square is, and then we'll figure out, just like before, how it opens up and where its position is on the graph. So now we're going to go, well, y is equal to x squared minus 4x, and then I'm going to put that in brackets just like we used to when we were calculating or completing the square. So now we're going to take a look at that. So the number is 4 divided by 2, and we square it, we end up with 4. So we're going to add 4 and minus 4 to this bracket. So x squared minus 4x plus 4 minus 4 plus 21. So that is what y is equal to. So now we continue, and we take the minus 4 and bring it out as before. So we got x squared minus 4x plus 4, and then we bring out a minus 4 plus 21. So now when we get our final answer, we get x minus 2 squared plus 17. So that means our vertex is 2, 17. Now, from before we said that our parabola opens up, so what we'll do is we'll just quickly kind of sketch where it is. So suppose that's 217. We know it opens up, so the parabola does that. So when we answer this question, we say the minimum of y is equal to -8. Sorry, not -8. It should be 17. And the minimum of y happens when x is equal to 2. And we're done.